So, sorry, like I was saying, distance formula we've been talking about the last couple of days. This is going to be more of a condensed version of it. You'll see exactly what I mean. We're going to go through this note sheet. You're going to be like, oh, that's it? And then we're going to get right to work. All right? So, here we've got 2 points on the graph. We got point A. Who can tell me what are the coordinates of point A? Where's point A at, Jordan?
I think like 2.5 and -4.
Very close. So it says right here we got 3 comma negative.
3.
Yeah, there we go. 3 -4. That's right. The coordinates are right there. That's right. 3 comma -4. Thank you, Jordan. And where's point B? Azalea, where's point B? 8 comma 8, right? So we have 2 pairs of coordinates. If we wanted to find the distance between these 2 points, we could very easily label these coordinates as x1, y1, x2, y2, plug them into our distance formula, and solve for D. But because we get a nice visual representation of where these 2 points are in space, let's go ahead and figure out how to find the distance by graphing. The first thing we want to do, step 1, is starting at either point. Earlier in the year, when we were working with graphs, we always wanted to start on the left. So if you want to remain consistent with that, just so it sticks in your brain, you can always start on the left, but in reality, it doesn't matter where we start. Okay? Think back to our translation lesson, right? Where we counted how many points over and how many points down. In that lesson, the direction that we were moving mattered, right? Because we were tracking A to A prime. We needed to know if we were going 6 units up or down, because that would change the rule that we write. Here, luckily for us, that's not the case, because when we square our numbers, even if we have a negative, it's going to give us the same perfect square. So it doesn't matter which point you start at. I'm going to start down here at point A, and I'm going to count the number of spaces going up or down. Well, if I'm starting at A, and I'm trying to get over to point B, am I going to have to move up this graph or down this graph, everybody? I'm going to have to go up, right? Let's count those spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to write 12 right there next to that line of little bumps on my graph. Remember, we're doing those bumps just so we can count and not accidentally miscount when we're going up this graph.
Is this going to be a rectangle?
Close. It's going to be a triangle, which is the next part of this unit, but we'll get to that.
That line can go right.
That was step 1. We're done with step 1. Now we're going to do step 2. Now we're going to count the number of spaces left or right until you land on the second point. Very straightforward. Easy to understand, hopefully. We're up here now. Are we going to have to move to the left to get to point B, or are we going to have to go to the right? We're going to have to move to the right. 1, 2, 3, 4, 5 spaces to the right. Okay? Very, very similar to some work that we've done earlier in this class. Counting up or down and counting left or right, using those little bumps on the graph. So we get 12 and we get 5. Now here's what we're going to do with those numbers. All right? Step 3 is we're going to square both of these numbers. So if we have 12 and we have 5, and we're going to, let me get a different color here. If we're going to square them, right, we're going to take 12 squared, and we're going to take 5 squared. What is 12 squared going to give us? 144. And what is 5 squared going to give us? 25. Thank you. I'm going to stop right there. Hopefully we're seeing a little bit of how this is similar to what we talked about yesterday and the day before. After we square both of those numbers, we're going to do step 4, which is to add them together. What do we get when we add 144 plus 25? Anyone got that one for me? Andy, what do we get? 169. That's right. 169. And now we're going to do step 5. We're going to take the square root of this number. Anyone know what the square root of 169 is, Hannah? 13, exactly. This is your distance. Just write units at the end. 13 units, box it up, we're done. Exact same thing as the distance formula, but because we have the visual element to our work, it's a lot simpler. We don't have to worry about placing our x1 and y1 and x2 and y2 in the right spots. That trouble is eliminated here because all we have to do is count. Now, when we say that our distance is 13 units, right? And we look at this and we say, well, we went up 12 and to the right 5. How did we get 13? What we're really measuring here when we're talking about the distance between these 2 points is, of course, the straight line distance between these 2 points. We don't have rulers in our supply box, so you don't have to do this, but if you connect point A and point B, this line here has the length of 13 units. That's really hard to see. I'm going to write over that in black. 13 units. Let me zoom in here. Now, with all 3 of these lines on the graph, what shape did we just draw, folks? We drew a triangle, right? Anyone ever heard of the Pythagorean theorem? Some of us may have heard it like on a TV show or something. It's talked about a lot. It's one of the most commonly, it's one of the most it's like considered the cliche like math equation if you're like watching a TV show about school or something. They're either talking about the Pythagorean theorem or they're talking about, I don't know. Pi, exactly, yeah. Great, Kenny, exactly, yeah. Shows, they use those cliches with math. Pythagorean theorem is kind of like one of the most widely known theorems in math. It's right up there next to our distance formula. And it's going to be what we talk about in the next part of this unit next week. So we're going to connect this work to triangles. It'll all make a lot more sense. We'll get some nice visual elements just like today, and we'll be good to go. Are there any questions on how we found the distance between points A and B following this process? Again, it's exactly the same as using the distance formula, but we're breaking it up step by step as opposed to solving a whole long equation each time we do a new step, if that makes sense. So this is another one of those lessons where if you know how to count, you are going to be good to go, as long as you can follow steps 3, 4, and 5 correctly. What questions can I answer before we get to work? Because that's all we got for notes. How are we feeling? Quick show of thumbs. Especially those of you staring at a Chromebook right now. How are you feeling about this?
Yeah.
Okay, good. Good.